Welcome back to my channel Math with Meenakshi. Today I'm going to solve this question. I found this question very interesting. This is based on a prism. So we know prism is a 3D geometrical shape with two congruent bases and they are connected by rectangular faces. The cross section of this prism is a trapezium. The trapezium has parallel sides of lengths 35 and 25 centimeter on a perpendicular height of 12 centimeter. The length of the prism is 120. Calculate the volume of the trough. Volume is equal to base area into height. Base is a trapezium, so area of which is half h times a plus b into the length of the shape given. So half 12 times 35 plus 25 into 120. 6 times 60 into 120, which gives 43,200 centimeter cube. Now subdivision B. The trough contains water to a depth of 6 centimeter. That is, the shaded portion is the region where water is there. Show that the volume of water is 19,800. Now this portion is also looking like a prism, but the height is reduced. It is 6 centimeter instead of that 12 centimeter. So we don't have the second side. So one is 25 and we don't have this side mentioned. So to get this, so we can approach it like this. For 12 centimeter, what is the increase in the length of the side? Increase of length, that is from 25 to 35. So it has grown 10 units. So increase in length is 10 centimeter. Same way, for 6 centimeter, let's calculate the increase. Increase of length would be 6 times 10 by 12, which is 5 centimeter. So the parallel side, the side which is parallel to 25, is now 25 plus 5, which is 30. Volume of water would be, again, the base area, which is the trapezium. The height of the trapezium is 6 centimeter into 25 plus 30 into that complete length, which is 120, 19,800 centimeter cube. Subdivision 2. Calculate the percentage of the trough that contains water. So percentage will be the portion that is containing water in comparison with the complete volume into 100, which is 45.8%. Next one. The water is drained from the trough at a rate of 12 liters per hour. That is, the water is removed from the trough. So the rate at which it is removed is being mentioned there. For 12 liters, it takes 1 hour, which is 60 minutes. So for let's take this 19,800 centimeter cube. So this has to be first mentioned in liters. So converting this to liters, this is 19.8 liters. Conversion is 1 centimeter cube is equal to 0.001 liter. So for 19.8 liters, it would be 60 into 19.8 by 12, which gives us 99 minutes. So this can be split as 60 plus 39, that is 1 hour and 39 minutes. Subdivision D. The water from the trough just fills a cylinder of radius r centimeter and height 3r centimeter. So the water from the trough is being filled into the cylinder. So obviously the volume of the cylinder should be equal to this water. Volume of cylinder is equal to 19,800. The cylinder's formula is pi r square h. Now instead of h, we must take height as 3r. So it becomes r cube. R cube is equal to 19,800 divided by 3 pi. Then r is cube root of 19,800 by 3 pi, which amounts to 12.8 centimeter. So this is the radius of the cylinder. Then subdivision E. The cylinder has a mass of 1.2 kg. 1 centimeter cube of water has a mass of 1 gram. So that means the water is filled into that. 19,800 centimeter cube of water has been sent into this. So if I convert this into grams, so 1 centimeter cube is equal to 1 gram. Obviously this will become 19,800 grams. So converting this to kg, this becomes 19.8 kg. Calculate the total mass of the cylinder and the water. So here let's add the cylinders 1.2, which gives me 21 kg.